Hello people. Radiator sizing. Normally when we select a radiator from a chart, the standard is for a delta T50, that's a 50-degree difference between the average surface temperature of the radiator and the desired room temperature. And normally think of this in terms of an average radiator temperature of 70 degrees and a room temperature of 20. However, with weather compensated boilers where we're trying to get high performance and constant condensing, Wiesmann suggests we design for a delta T of 20. So that's a difference of 20 degrees between the room temperature and the mean water temperature of the radiator. In fact, they don't actually say it in those terms, they say 50-30, so that at full load the radiator is running at 50-30, which gives us an average radiator temperature of 40 degrees and I jumped to the conclusion of 20 degrees target temperature in the house because it conveniently comes to a nice number. However, the theory is still the same. Okay, so how do we calculate the size of the radiator? Obviously, if we reduce that mean temperature, we reduce the output of the radiator, and we need some way of working out what size radiator to select. And the catalogues are put at delta T50, so they're usually published at delta T50. Some manufacturers do give you all the other ratings, but if you were to go for a radiator manufacturer who only gave the ratings of radiators at delta T50, you'd need to be able to calculate the difference. So this is the method according to SIBSE. The conversion factor, there's a series of conversion factors for radiators, and the conversion factor we're interested in here is F1. So F1 is equal to the actual delta T divided by the catalogue delta T to the power of 1.3. So the actual delta T is the delta T that we're actually looking for, which is 20. Catalogue dt is the one I've stated already, 50. So 20 divided by 50 to the power of 1.3, 0.4 to the power of 1.3 ends up with an answer of 0.3038. So this is actually the new output adjusted for the reduced delta T. So if we were to select a 1000 watt radiator or 1 kilowatt radiator from the catalogue of delta T50, this in fact would only give us an output of 303.8 watts at delta T20. So you can see it's considerably reduced the output. To find the new radiator from the catalogue, we use the reciprocal times the output required. So the reciprocal, basically 1 divided by the number we had here, gives us the reciprocal, which is 3.291. Right, so for 1 kilowatt, 1000 watts, 1000 times the reciprocal, 3.291, gives us the new output. So we need to select from our chart a delta T50, a radiator of 3291 watts output, and that will in fact give us an output of 1 kilowatt. The new radiator is more than 3 times the size of the radiator at delta T50. So if you look at some of the videos I've done, I think I've done one where I show a property where I've sized radiators to delta T50, and it's an old Victorian house, delta T20. It's an old Victorian house, and the radiators take up basically an entire wall. Works brilliantly, but yeah, a lot of people wouldn't want a radiator that size. However, in modern houses with good insulation, it's probably going to be a little bit more realistic. Some of the radiators used at delta T50 actually look like tiny postage stamps on the wall, and the new design delta T20 is going to look far more reasonable. So any questions, please just make a comment.